Mercury is a planet of extreme and violent contrasts. As the closest planet to the Sun, orbiting at an average distance of just 58 million kilometers, 0.39 astronomical units, it receives about 7 times more solar energy than Earth. Daytime temperatures on its sunlit surface can reach around 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead. Yet at night, with no thick atmosphere to trap heat, temperatures plummet to about -180 degrees Celsius, -290 degrees Fahrenheit, colder than many regions on Pluto. The reason is simple but dramatic. Mercury has almost no substantial atmosphere, only a thin exosphere composed of atoms blasted off its surface by solar wind and micrometeorite impacts. Without air to distribute heat, there is no weather, no clouds, and no insulation. Adding to the extremes, Mercury rotates very slowly, completing one rotation every 59 Earth days, while orbiting the Sun every 88 Earth days. This creates a solar day, sunrise to sunrise, lasting 176 Earth days, meaning the same surface can bake in sunlight for months before enduring months of darkness. Despite its proximity to the Sun, radar observations have revealed water ice hidden inside permanently shadowed craters near Mercury's poles, where temperatures remain below -170 degrees Celsius, -274 degrees Fahrenheit. Mercury is not simply a scorched rock. It is a world where inferno and deep freeze exist side by side, shaped by physics that produces some of the most dramatic temperature swings in the solar system. The closest planet to the Sun, Mercury orbits the Sun at an average distance of about 58 million kilometers, or 0.39 astronomical units, making it the innermost planet in the solar system. Because of this proximity, it receives roughly 7 times more solar energy than Earth, with solar radiation striking its surface at intense levels. Unlike Earth, however, Mercury has no thick atmosphere to reflect, trap, or redistribute that heat. It possesses only a tenuous exosphere made up of atoms such as sodium, oxygen, and potassium, which is far too thin to provide insulation. As a result, the hemisphere facing the Sun absorbs energy directly, and daytime surface temperatures can soar to around 430 degrees Celsius, 800 degrees Fahrenheit near the equator, hot enough to melt metals like lead and zinc. The planet's rocky surface, composed largely of silicate materials and metals, heats rapidly under direct sunlight. Yet distance from the Sun is only part of the story. Mercury also rotates very slowly, completing one rotation every 59 Earth days, which allows sunlight to bake the same region for extended periods. Combined with its lack of atmospheric buffering, this creates some of the most extreme temperature contrasts in the entire solar system. Nights colder than Pluto. When Mercury rotates away from the Sun, its surface cools with astonishing speed. Nighttime temperatures can plunge to about -180 degrees Celsius, -290 degrees Fahrenheit, colder than average surface temperatures measured on Pluto, which sits far beyond Neptune. The reason is direct and unforgiving. Mercury has almost no atmosphere to retain heat. Its exosphere is so thin that it cannot trap infrared radiation or circulate warmth from the day side to the night side. On Earth, our dense nitrogen-oxygen atmosphere acts as a thermal buffer, absorbing, storing, and redistributing heat through winds and weather systems. Even deserts on Earth rarely experience temperature swings of more than 40 to 50 degrees Celsius in a single day. Mercury, by contrast, experiences a staggering temperature difference of over 600 degrees Celsius between day and night. Once sunlight disappears, there is nothing to slow the escape of heat into space. Adding to this effect is Mercury's slow rotation. It takes 59 Earth days to complete one spin, meaning its night side remains in darkness for weeks at a time. With no clouds, oceans, or atmospheric insulation, the surface radiates energy directly into space. The result is one of the most extreme thermal environments in the solar system, a planet that alternates between furnace-like heat and deep freeze with relentless regularity. A day longer than its year. Mercury rotates remarkably slowly, completing one full rotation on its axis in about 59 Earth days. At the same time, it orbits the Sun in just 88 Earth days. These two motions are locked in a rare 3-to-2 spin, orbit resonance, meaning Mercury rotates 3 times for every 2 orbits around the Sun. This gravitational relationship, stabilized by the Sun's tidal forces, creates unusual solar dynamics on the planet's surface. Because of this resonance, a single solar day on Mercury, measured from one sunrise to the next, lasts about 176 Earth days, which is twice as long as its year. As a result, any given location on Mercury can experience weeks of continuous, intense sunlight, followed by weeks of complete darkness. During the prolonged daylight period, surface temperatures can climb to around 430 degrees Celsius, 800 degrees Fahrenheit. During the equally long night, temperatures can fall to about -180 degrees Celsius, -290 degrees Fahrenheit. The extended duration of heating and cooling, combined with the absence of a heat-retaining atmosphere, amplifies the planet's already extreme temperature swings. Mercury's slow rotation and orbital resonance are key reasons it endures some of the most dramatic and prolonged thermal cycles in the entire solar system. No real atmosphere to protect it. Mercury does not have a true atmosphere like Earth or Venus, but instead possesses an extremely thin exosphere composed of individual atoms such as sodium, potassium, oxygen, helium, and hydrogen. These atoms are constantly blasted off the planet's surface by intense solar radiation, charged particles from the solar wind, and micrometeorite impacts, a process known as sputtering. Because this exosphere is incredibly sparse, with pressures trillions of times lower than Earth's atmospheric pressure at sea level, it cannot trap heat, create clouds, or support weather systems. There is no wind circulation to move warmth from the day side to the night side, no greenhouse effect to retain infrared radiation, and no insulating layer to moderate temperature swings. As a result, the hemisphere facing the Sun absorbs radiation directly, heating to around 430 degrees Celsius, 800 degrees Fahrenheit, while the dark side rapidly radiates its energy back into space, cooling to about -180 degrees Celsius, -290 degrees Fahrenheit. The absence of a substantial atmosphere is the central reason Mercury experiences a staggering temperature difference of more than 600 degrees Celsius between day and night, one of the most extreme thermal contrasts anywhere in the solar system. The Sun looks massive from Mercury. From Mercury's surface, the Sun would appear dramatically larger than it does from Earth, on average more than twice the apparent diameter, and therefore over 4 times the apparent area in the sky. This is because Mercury orbits at about 0.39 astronomical units from the Sun, compared to Earth's 1 astronomical unit. The intensity of sunlight is correspondingly extreme, averaging roughly 7 times stronger than what reaches Earth. Mercury's orbit is also highly elliptical, with an eccentricity of about 0.21, the most elongated of any major planet. This means its distance from the Sun varies significantly during its 88-day year. At perihelion, its closest approach, about 46 million kilometers from the Sun, solar radiation is roughly 10 times stronger than what Earth receives. At aphelion, around 70 million kilometers away, the intensity drops substantially. These variations cause noticeable changes in the Sun's apparent size in Mercury's sky and amplify surface heating differences over the course of its orbit. Combined with its slow 59-day rotation and lack of a heat-retaining atmosphere, these orbital extremes contribute to the planet's dramatic temperature swings, reinforcing Mercury's status as one of the most thermally volatile worlds in the solar system. Ice in the shadows. Here's the shocking twist. Despite the scorching daytime heat, Mercury contains water ice. Radar observations from Earth first hinted at this in the 1990s, and NASA's Messenger spacecraft later confirmed it. Deep craters near Mercury's poles never receive direct sunlight. These permanently shadowed regions remain incredibly cold enough to preserve water ice for billions of years. Fire and ice exist on the same planet, separated only by sunlight. How did ice get there? Scientists believe the ice likely came from comet impacts or water-rich asteroids. When these objects struck Mercury, water molecules were delivered to the surface. Most of it would have been lost quickly due to heat, but any water that migrated into permanently shadowed craters could survive. Over time, more impacts may have added to these frozen reserves. Even on the closest planet to the Sun, water found a way to hide. A surface scarred by violence. Mercury's surface is heavily cratered, resembling Earth's moon. With no atmosphere to burn up incoming meteoroids, impacts are frequent and direct. These collisions shape the terrain and may help redistribute material, including water molecules that eventually settle into cold traps. Mercury's extreme temperature swings also cause rocks to expand and contract dramatically, gradually breaking down the surface over time. A planet with a giant core. Mercury has an unusually large iron core, making up about 85% of its radius. This massive core contributes to its relatively strong magnetic field, surprising for such a small planet. However, the magnetic field is much weaker than that of Earth and offers little protection from solar radiation. That radiation constantly bombards the surface, contributing to the stripping of particles and maintaining its thin exosphere. A world of brutal extremes. Mercury proves that proximity to the Sun doesn't simply mean hot, it means instability. It means violent cycles of heating and freezing. A planet where ice survives in eternal darkness while nearby regions melt under relentless sunlight. Its temperature difference, over 600 degrees Celsius between day and night, is one of the most extreme in our solar system. Mercury isn't just a hot planet. It's a study in contrast, survival, and cosmic harshness. Mercury is a planet of fire and ice, a world where direct sunlight from the Sun drives surface temperatures to around 430 degrees Celsius, 800 degrees Fahrenheit. Yet permanent shadows preserve frozen water for billions of years. Despite orbiting just 58 million kilometers from the Sun and receiving up to 10 times more solar radiation than Earth at perihelion, Mercury hides water ice inside deep polar craters that never see sunlight. Radar observations from Earth first hinted at this ice in the 1990s, and NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, confirmed its presence using neutron spectroscopy and imaging data. In these permanently shadowed regions, temperatures can remain below -170 degrees Celsius, -274 degrees Fahrenheit, cold enough to trap and preserve volatile materials. The same planet that endures a staggering 600 degrees Celsius temperature swing between day and night also protects ancient ice deposits in eternal darkness. With a 59-day rotation, an 88-day orbit locked in a 3:2 resonance, and almost no atmosphere to moderate conditions, Mercury challenges assumptions about how heat and cold behave near a star. It is not simply the closest planet to the Sun, it is a world of extremes, where physics creates both inferno and deep freeze side by side, proving that even the harshest environments can hold unexpected complexity.